Welcome back to section 7.1. We're still talking about logs, and we're going to talk about some properties of logs. First one is called the power property. Log base b of m to the n power. The power property allows us to move that exponent into that coefficient. So take the exponent and just goes right out front. Log base b of m to the n is n times the log base b of m. Now, a very important thing next when we get into solving is using what's called the inverse relationships of logs. Log base b of b to the x equals x. Now, if you notice, the base of the log is b and the base of the exponential is b. When they're the same, they cancel each other out. That's when we're in logarithmic form. B to the log base b of x equals x. You can see the base of the exponential and the base of the log are the same. They cancel each other out. That's what we're using when we're working with these problems. Now, we also have the change of base formula. Since our calculator does base 10, it's helpful to be able to calculate different logs even if our log isn't base 10 in the original problem. To do that, log base c of a, it's the log of a divided by the log of c, the base. So it's the log of the number divided by the log of the base, and that's using the calculator. So to start off, some examples use the power property. So with that power property, the exponent just slides out to become the coefficient. So we just write that as 7 times the log base 3 of x. For b, the exponent becomes the coefficient. It's 2 log base 5 of x. And for c, the 3 goes out front, 3 log of x. Remember, that's log base 10. No base shown, the base is 10. Let's go to the next page. And we're going to simplify using inverse relationships. Now, if you look, 8 is the base of the exponential and 8 is the base of the log. They're going to undo each other. We're left with just x. Problem number 15, log base 7 of 7 to the 2x. Base is 7, base is 7. They undo each other. We're left with 2x. 5 to the log base 5 of 2x. The 5 and the log base 5 cancel each other out. We're left with 2x. Now in problem number 17, the base of the log and the base of the exponential are not the same. But we can rewrite 64. 64 is the same as 2 to the 6th. So what we have here, log base 2 of 2 to the 6th raised to the power of x. Using our exponent rules, it's log base 2 of 2, and then multiply those exponents, 6x. Now that the base of the log and the base of the exponential are the same, they undo each other. We're left with 6x, and there is our answer. You want to see if the base of the log and the base of the exponential are the same. And if they do, they're inverses. Here we're going to use our change of base. So log base c of a, we write that as log of a over the log of c. So the log of the base goes in the denominator. Just keep that in mind. So for number 18a, it's the log of 24 divided by the log of the base, which is 6. When you type that in, you're going to get a value of 1.774. For b, change of base formula, log 68 over the log of the base, 9. Remember, we're using that log base 10 for these. You're going to get about 1.920. And for part C, the log of 7 halves, don't worry, the calculator's going to do the work for us. divided by the log of 5. And when you type that in, you get about 0.778. Now for 19. What we're going to do is we're going to solve these. Now there's a couple different ways to do this. One of the ways we can do this is by using our rules and rewriting this from exponential to logarithmic form. Or what we can do is we can take the log of both sides. So we have here is the log base 2.25 of 5 equals the log of base 2.25 to the x. So when we do that, on this right-hand side, they cancel. So we have the log base 2.25 of 5 equals x. Now, to find out what x equals, we can use our change of base. It's the log of 5 divided by the log of 2.25. So x equals, and when you type that in, you get about 1.985. Now for number 19b, we're going to divide both sides by 2 first. 8 to the x equals 64. Now, what you could do is then take the log base 8 of both sides. Log base 8 of 8x, log base 8 of 64. The log base 8 of 64 is x. So x equals the log of 64 divided by the log of 8. And when you type that in, you actually get a nice answer. X equals 2, an exact number. Since the base for C is 7, we can take the log base 7 of both sides. So we get 9x equals the log base 7 of 15, and then divide both sides by 9. Log base 7 of 15, all divided by 9. That's the exact answer. Now, a little bit trickier to find this on the calculator. What you would do, you would take the log of 15 divided by the log of 7, hit enter, and then divide that whole thing by 9, and you're going to get an answer of about 0.155. For D, now we have the log base 4. We want to undo the log. To undo log, we use exponential. The base of the exponential is going to be the same as the base of the log. 4 raised to the log base 4 of x, and 4 raised to the negative first. So what happens here is the 4 and the log 4 cancel. So we get x equals 4 to the negative first. So x equals, and 4 to the negative first is 0.25 or 1/4. Whatever you're more comfortable with, there's your answer. For E, we have the log base 2 of both, or log base 2. So to undo, we're going to use the exponential. The base of our exponential is the base of the log 2. These cancel, left with x minus 4 equals 2 squared, which is 4. Add 4 to both sides. X equals 8. And then for the next one, 8 to the log base 8 of 4 equals x. Now, we could go through and do inverses, but we don't need to. 8 and log base 8, they undo each other. So we're left with 4 equals x. There's our answer. X equals 4. Okay. Thank you for your time, and I will see you in the next one.